fixed by upper meridian passage of the Sun. On the date of 3 August 2018 at GMT 10:18:20, they are positioned 36.4 degrees north, 0.27 degrees 36.2 minutes west. You observe Sun's highest altitude as 71 degrees 08.2 minutes from the lower limb and the azimuth 180 degrees. Instrument correction plus 2.2 minutes. I hate 22.2 meters. What is your position? We will solve this problem in 4 steps. The first step, finding HO, our 6th altitude, 71 degrees 08.2 minutes. So we apply corrections to this value and we will finally obtain H height observed. 21 degrees 08.2 decimal given here, and instrument correction plus 2.2 because it is given plus. So we will obtain height sextant 71 degrees 10.4 minutes. We will apply to this dip correction. Dip correction will be always minus. And where we will find this, beginning of the almanac, we have correction table. For the height of our bridge, 22.2 meter, altitude correction table, dip correction. As you see, 22.2 between these two values. This 22.2 very close to 20 degrees, no need to make calculation. I am taking as dip correction minus 8.3 minutes. And now we found 8 apparent, 71 degrees 0.2 minutes. Now we have to make correction caused by the celestial body. For the Sun, we have to make semi-diameter, parallax, and reflection in the same table, in the same correction table altogether given, but we have to look to the table with the sky object, which limb we used, and what is the month. We are looking for the Sun and the month August. Between April and September, we will use this clone. And the other value, apparent altitude and lower limb. What is our apparent altitude? 71 degree 0.2 minute. Lower limb clone, our value plus 15.6 as main correction of the Sun. Finally, we found 71 degree 17.7 minutes height observed. So we found our Sun's position, our apparent horizontal system. Now we have to find sky object on the celestial sphere. In order to find this, we need Greenwich Mean Time, because we will use almanac. In almanac, the position of the sky objects given according to GMT from the Greenwich, GHA given from the Greenwich, angular distance from the equator according to Greenwich Mean Time. In our question, it is given as GMT. Easily we can use this, but in practice, special watch, which we call it chronometer on board, and this chronometer gives always Greenwich Mean Time. Daily, we record its error, chronometer error logbook. We enter how much it is fast or slow. So you can look to the your chronometer when you make your observation, after you make your observation, and make slow or fast correction, then you will obtain Greenwich Mean Time easily. Or other way, you can look your watch on your arm. You can apply zone description to your zone time. For if you are at east longitudes, you have to deduct. If you are in west longitudes, you have to add to your zone time in order to find what is the GMT at your observation time. So let's look up reality now. In our question, it is given already as GMT 10 o'clock. Almanac giving where's the sun, hourly, Greenwich, hour angle and declination. We can read and note here. We will read. I will show you where we are looking to the in the almanac. But our time is not 10 o'clock. We have 18 minutes 20 seconds. Our observation occurred in this time. The sun passed over us at this moment. So we have to find exactly at this particular time where is the sun. There's two ways to find this value. One is mathematical. In 60 minutes, sun travels 15 degrees. If sun travels in 60 minutes 15 degrees, 80 minutes 20 seconds, how much does it travels? You can make interpolation. And you can find easily 4 degrees 35 minutes. Or other way, you can look to the increasements page at the rear of the Admiralty Almanac, and you find the yellow pages 18 minutes and 20 seconds. So our value, this one, degrees and minutes. If you confuse was it minutes or degrees, whatsoever, you have to look to the top of the columns. We are also writing here. Add it up always. GHA always increasing every minute. So we are adding it up, so we can find the GHA value of the sun for 10, 18, 20. Let's speak about the declination also. Declination for at 10 o'clock, you can see at 10 o'clock, declination of the sun. Here only you see 27.5 minutes, but you have to take this value also. In order to not write every time, every hour, this value, as you see, it is going on. So the declination is north 70 degrees 20.5 minutes. We are checking previous value 28.2 and reduced 0.7 minutes, decreasing. Also you can find daily declination value for that day. You can find here at the end of the page 0.7 minutes. You can see from here also. We found also declination D value minus. I wrote minus in order to not forget it is decreasing. In 1 hour, if it changes 0.7 minutes, 18 minutes 20 seconds, how much does it change? We can make interpolation. Or increasement page, there's also for 18 minutes interpolation already given. V or D value, you can use your value, D value 0.7. For 18 minutes, it is changing 0.2 minutes. So we found also how much changes in 18 minutes. So we apply it also. We know now at our observation time, where is the sun? We have 4 formula these three formula, one of them will be chosen. And zenith distance will be used in all these formulas. So zenith distance means 90 degrees minus HO. We found HO here. Just mathematics. Making these calculations like this, I am taking 1 degree as minute here. After that, not in order to not confuse. So I am making solutions like this. If you prefer, you can use it. We can obtain 18 degrees 42 minutes decimal 3 minutes zenith distance. Let's check the other three formulas. The first one, latitude equals zenith distance plus declination. Latitude equals zenith distance minus declination. Latitude equals declination minus zenith distance. Which one do we have to choose? If latitude and declination have the same sign, north, north, south, south, in this case, we will use number 1. If latitude north, declination south, or the opposite of it, we will use the second one. They are contrary to each other. If they have the same sign, latitude north, declination north, latitude south, declination south, but if the latitude smaller than declination, you have to use the third formula. 17 degrees 27 decimal 3 north, our declination. Now latitude bigger than declination, 70 degrees, and latitude 36 degrees given as GR. We are choosing in this case the first equation. Latitude equals to zenith distance plus declination. Zenith distance we found here plus our declination, which is we found from the almanac. When we add them up, we will have our latitude 36 degrees 25 decimal 2 minutes north. The sun just above us. So this means GHA of the sun is our longitude. We have two formulas for longitude. Local hour angle is equals to Greenwich hour angle minus longitude if it is west. Longitude local hour angle equals Greenwich hour angle plus longitude if it is east. Local hour angle is 0 in our case because the sun just above us. There is no angular distance between the sky object and us. Our meridian and the sky object hour angle are equal to each other. There is no angular distance between them. The local hour angle 0 degrees equals Greenwich hour angle we found here already, calculated here, we found it, and this value goes the other side as minus 0 degree minus 333 degree. Of course 0 degree means 360 degrees. 360 degrees minus 330 degrees 2.1 minutes, and the result will be our longitude. Isn't it easy?